Hello, everybody. So we're back for the next lecture on LabView. This is going to be a short one. We're going to show you how to use the VI that you just created in the previous lecture. Hopefully you've done that. One of your assignments for this, this part of this week will be to build in at least one of the following: a square wave or a triangle wave or both into the previous code that you finished in lecture 6. Okay, so here we go. What we're going to do is we're going to build a little piece of code that is going to mix in some white noise, okay, to our sine signal. Again, this is very useful for people to simulate what might happen in a real experiment where, say, you're using a microphone to pick up sound and there's going to be all kinds of noisy stuff going on. And it's good to simulate that signal so that you can figure out how to process that. Okay, so this is what we're going to do. All right, so let's get started. All right, so what I want to do first is actually grab the VI that we just made. So how do we do that? Okay, so what we do is we just right-click, and notice I'm on the front panel here. I'm just going to right-click, and I'm going to go all the way down to select a VI. Okay, now when I do that, I can go up into my directory, and I was using this waveform simulator teaching. That's the one we built in lecture 6. I'm going to grab it, double click, and there it is with that funky looking icon. I hope you did a better job on your icon than I did. Put it down, and notice it's wired up the way that I want it to. Now notice that I couldn't double click on this and open it up if I want to. Okay, I'm going to close it for a second. And I want to put something out to you that I forgot to do last time. So I am going to double click on it and open it. Up here, this number of samples should be set to representation of I-32. Now right now it's probably double because I forgot to tell you to do that. So what you're going to do is you're going to go in and change it to I-32. So remember, you're going to right click on number of samples. You come down to representation, you click on I-32 and you're done. And then you're going to save, right, I just saved it, and then close it, okay? Because I forgot to do that. Anyway, so here's our wave sim. All right, now I'm going to right click here, and I'm going to say create a constant. Remember, these are those clusters, right? And the first thing here is the number of samples, and the second thing is the sampling rate, remember? All right, so I'm going to come in here and I'm going to say I want 200 samples for this example code, and a sampling rate of 10,000 hertz instead of 1,000 hertz. Okay, and now I'm going to right click on this, create constant again, and I'm going to have 100 for my frequency. My amplitude is going to stay at 1, and I'm just going to keep it sine wave. Okay, so what would I like to do? I would actually like to add some noise to the signal. So we know that the signal right now looks just like a regular old sine wave, but I'd like to add some noise to it. So I'm going to go and look for some white noise to add to my signal. So I'm going to right click. I'm going to come down here to signal processing, to signal generation here. And then I'm going to come over and find Gaussian noise. And actually, that's what I want. I want Gaussian white noise. Okay, it just means that it's taken from a Gaussian distribution. Anyway, I'm going to grab it, and I'm going to put it down here. Okay, actually move it over even more than that. Okay, so I need to I take the signal that we get out from here, add in some white noise, right? But to do that, I need to make sure that I have the same number of samples of white noise as I do my signal. So over here, I have 200 samples. I better get 200 samples here. So I need to unbundle and wire this in, because I don't have to just hard code it as 200, although this is kind of hard coded, meaning it's not controlled by the user. But again, you're going to see that we're actually going to use this code as a sub-VI for lecture 8. Okay, anyway. So I'm going to grab and unbundle by name right here. And I'm going to wire my cluster in. And I'm going to take the number of samples and wire it into the number of samples. You can see up there in the context help on my screen. Number of samples is flashing. And now the output now is going to be 200 samples. And I'm going to keep my standard deviation on wire constant and at the default of 1. And I'm not going to do anything else with that. Okay. Now I have to add that to the signal that's coming out of this wave sim. All right, so first I'm going to get a plus sign. Stick that here, and I want you to notice that this coming out of this signal generation is an array, right? It says right here 1D array. Okay, so when I add, so when I come in here and I have to unbundle that signal, right? So first let me get an unbundle. When I add, I'm going to be adding it to another array point by point. Okay, I'll show you what that means in a minute. I'm going to wire this up. And I don't want times. And notice we didn't do this before, but I'm going to click and I can just say I want displacement, right? I want the sine wave. Okay, here. Now, what does this mean? So imagine you have the first point of the sine wave and then the first point of the noise. They're going to get added, and then that's part of the output. Then the next point of the sine wave and the next point of the noise get added and then put out, right? So the output is an array that's just the addition, point by point addition of the array. It's like adding two functions on a graph, right? You add point by point to get a new function. Same idea here. Okay, so now I not only want to output the addition of these two, I'd like to actually plot both things, the sine wave that doesn't have any noise and the noisy sine wave on the same plot. So I'm going to come over here and I'm going to grab a waveform graph right here. Okay. And I am going to build an array. So if I come over here to the waveform graph, which is way over there, I see that I need to build an array, right, to put into this waveform graph. Okay, so let's see. So we're going to build array. Where's our build array? There we are. And I'm going to put in my noisy sine, and then I'm going to grab another one and put in the actual just displacement by itself. That's that. And then now that can go out to my waveform graph. Okay, that wasn't that clear on this context help, just FYI. All they show you is this, where it goes into a cluster into the waveform graph. We used this before, we did it with a cluster, but you can also do this, plot two graphs at a time just by putting two arrays. Remember, the waveform graph can take in an array, and then you just have one plot on the graph. But it can actually take in a multi-dimensional array. So this array now, if you look in here, this is a one-dimensional array, right? So it's just a bunch of numbers. Okay. This here is also a one-dimensional array, just a bunch of numbers. But when you put them both together, it's like having a matrix, right? So you have a bunch of numbers and a bunch of numbers, two rows, okay? And that's going into the waveform graph. All right. So far, so good. I haven't really put any comments on here. Probably should do that. I'll leave that to you. And let's see if this will work. There we go. Looking good. Now you can see I have a red line, which is the sine, and the noisy sine. And what I'm going to do here is show you how to get this legend to work right. So first of all, I don't really like the red. I don't feel like I actually don't like the white. So I'm going to right click on this and color, make it kind of a more yellowy color. I think you can see the red better with the sort of yellowy color. And then I can put in here and say that the yellowy color is the the signal for the sine plus noise. You can say whatever you like. Oh, I didn't want to return. Just right click off of it or click off of it, and I gotta fix that space. Okay, and then here, this is just signal. Okay, I'm not putting sine. I'm just saying it's signal, right? Signal and signal plus noise. Okay, all right, cool. So there you go. And you might want to make it a little bigger. It's a little small. All right, there we go. Okay, so this is going to be used as a sub PI, which means we need to go up here and actually make, you know, the icon like halfway decent right here. Oh, this side. There we go. And I'm just going to make the icon, I'm just going to go over here and make a different color, maybe green. And I'm going to put in here, you know, noisy. Yeah, you know, I hope yours is working better, but mine is it gets very, very blurry. It really shouldn't be like that. Anyway, hopefully yours works better. Sine. Okay, fine. It doesn't really matter. All right. And then I'm going to come over here, choose a pattern, Now the patterns, I really only have, I don't have any outputs yet. I haven't done that yet. So I better go to the front panel, sorry, to the block diagram and make those outputs, because the user is going to want the noisy sign and the not noisy sign. They're probably going to want both of those. So I'm going to right click here and create an indicator for that. And that's my Gaussian noise. Oops, that's not what I want. No, we want the noise plus. Okay, here we go. We want the noise plus the sign. Okay, so this is the noisy sign. And here is just the sign without being noisy, the not noisy sign. So I'm just going to call that signal. Maybe I should call those noisy signal plus noise to match our graph. So let me do that. Signal plus noise. There we go. Okay, so now these two things are here, and I'm just going to scoot them over a little bit. I'm not going to make them a cluster, but you're free to do that if you'd like we had before. And I'm going to choose a pattern. We only have outputs. We don't have any inputs, so it's a little unfortunate as a pattern, but I'll just choose this. And then on the right-hand side for outputs, okay, I'm going to put the signal plus noise, and then I'm just clicking, by the way. Okay, signal. All right, and I'm saving. Okay, so this is going to be used in the next piece of code that we're going to write in lecture 8. So this is just a little bit of a short lecture. I would make sure that you've done all this, and also in your homework you're going to be modifying the code you did in lecture 6. Okay, bye.